And so we are live. Hello everyone. Welcome back. I have found this really good music that I really like. It is NCS, although stuff after it is not. So just to be safe, I'm gonna loop it. This is Niviro, Time for Polka, NCS release. It's a pretty good song actually. Yeah, I love it. It's pretty good. It's time for polka, yeah. It's a pretty good song actually. Nice vibes. Don't forget to hydrate, people. I drink too much water, by the way. I don't have to drink that much. Yeah, we're gonna start with just 5 minutes of me just zoning out because I I cannot just start stream straight away. While I'm at it, might as well pop out chat, send my OBS to workspace 7. So here's what I learned. I learned that I am completely terrible at um what was I bad at? I forgot. Uh Bruh. What was I supposed to say? Yeah, see, I completely just I cannot think today. Anyway, having fun. Please check the resolution, which is not optimal. I mean, are you streaming at? Is it seriously streaming at 480p? Are you kidding me? Please check video resolution. Um, I don't think I can change them while I'm streaming. Yeah, guys, I'm really sorry. I cannot think. Yeah, I cannot change this resolution. I wonder what the options are. Because I think what I should do. Oh wait, the output resolution. I have to change that one. It's 1092 by 614, but it should be 1080p by whatever 720, I think. Oh, oh, that's how it works. Downscale factor. Sorry, filter. Yeah, okay. Custom FPS values. Oh, nice. I should really visit this tab a little later. You know what? It might make oh yeah, this song has ended. Let's launch our usual playlist. I have noticed that I should probably update my hydrate image and maybe put something else on it, especially since I have a really nice picture that I could put there. Not sure about it though. I want to make it so that this hydrate image could be changed on like some schedule, but so that it would be like sort of random, so that every time I open it, it's a different picture. I wonder if I can do that. I guess if you like write a program that just shows a static picture and then just changes it on a schedule, and then you use that as the, like, you just scale that program screen to full screen. You can actually animate the be right back screen then, but that requires having a program always open. um, Not the best thing in the world, to be honest. All right. Think it's time. Don't give up. Dun. Oh, yeah, I really should fix my mic. Oh, I'm sorry. I think I took some pills not to cough. They don't seem to work. So we are probably gonna be live for about until 12 a.m. Not sure about it. We'll see. We'll see. Oh wait, Discord is open. That's what draining my CPU probably. Let's quit Discord. Okay, OBS. Yeah, seems to go down. Web content. So that's a browser. That's probably YouTube. Okay. So, after I had completed the movement, I think. What did I say last stream? What did I promise? I forgot. Well, point is, after I had completed something since last stream. Jeez, what did I say? I was. Oh, we can actually look it up. Hang on. I need to remember what I was doing. Let's see here. Compile commands. No. This is a useless thing. So we want to edit sprite support and add a character sprite. Oh yeah, that's what I wanted. So I actually did do that. So I have sprite support already, and I added a character sprite. And right now, I am just gonna rebuild just in case and run. And this is what it looks like. So I am not sure. I mean, this is a terrible pixel art. I'm gonna get rid of this, by the way, because it looks horrible. Like, it just does. There's no doubt about it. It looks ew. Um, but as you can see, it sort of works, kinda. I mean, sort of. You see the lines? I'm not sure if you can see them. Can you? Yeah, you can see them. At least on my side. So there are like random lines popping up. Um, and those are just a single pixel width thing. So that probably has something to do with um, floating point precision. So I'm gonna see what I can do about that, because it's not working the way I wanted to. But here's here's how it works. So I want this better version of this grass, which we'll make a little bit later. I want better version of this grass to be put into the world, so that and what I want is, I want it basically to be filled in, and I want to see none of this blackness over here, right? I want, because the reason why it's happening is, like, if I move a little bit to here, Is there any box that's like on the edge? No? Well, so the reason why that's happening is you can see that it's, first of all, not even grid aligned properly, right? Because I know the boxes are grid aligned, but this stuff isn't even grid aligned. Secondly, you see there's a huge thingy here, so we need to move this entire canvas over. Um, and we basically want to somehow fill it up so that when we move the actual like squares, you see how this texture stays in place within this boundary, right? Doesn't move inside of it. So I want this to be stationary like squares, you know, in a grid, but I want this to fill up all the space. Because even if I make it smaller, you can still see right here, right? See that? That is not supposed to be there. And the same goes for this stuff as well. Right, that's a box over there. And so I am not sure how to do that. I tried drawing on paper and I honestly do not know. Um, so in that case, let's open up GIMP. Oh wait, is it looped? I think it's looped. Let me unloop that. Okay, GIMP. Let's move that to workspace too. We're not gonna make it until 12 a.m., but I really need to finish. But I want to keep going. Not sure what I should do. Anyway, open. Oh wait, not open. New. So actually, let's create a new one. Let's make that 32 by 16. It's pretty small, but it's gonna be fine then. So let's say I want to put this grass down. Right? I am mostly interested in where do I put the grass, right? Because like I want the grass to be aligned some kind of grid. So this is the grid. Better say this is like the edge of the screen right there. And let's make that, I don't know, some nice red. So I want the grass. I could place it right here, right? But then if we move the next frame, let's just suppose that we are aligned on the grid right now. So let's say this is the actual, like let's say we're standing at 0, 0, and the width of the frame is like exactly in such a way that the actual grass block should stay like this, like right in the corner. If we move 0.5, the grass block should move a little bit over, right? But the issue is, how do we calculate this offset? So let's think of it this way. If we start at, if we stand at, say, 0, 0, and we shift, um, oh my God, this is going to be hard. So basically, we need to, let me draw this on paper because I cannot do this in GIMP. It's just not going to work. I don't want to draw it on GIMP. It's just going to take more time. So let's say that, oh, sheesh. Our our screen is not always multiple of, Jesus. You know what? It seems like I'm wasting my time here because we already have the algorithm to calculate the position right here. We already know how to calculate this position. If we just take this, this is the position. Oh, go away. Let me just real quick put that on the next line. If we take all of this, so this will work, except that this here, we basically need to calculate the position relative to the camera. The camera position should be, so let's make it like this. Let's make it say I here and J here. Oh wait, that's not gonna work. Let's make it just I and J. We're gonna add this in later, like the actual math for calculating the position relative to the camera. We're gonna do that a little bit later. For now, let's just make it IJ. It will look weird, but it should be aligned perfectly. So now, if we compile, why does it say compilation finished when it's not? Oh, because the previous one finished. Okay, now if we run this, it will be offset. So basically, it will be in line with the character. But now we need to make it so that when we move, if we are not aligned to the grid, like see here, like I'm clearly, there's a small gap here. Like if I move a little bit off, right? See, I'm not aligned, but this pixel, these things, they should be aligned to the grid on which this stuff is placed. And by the way, their position here, I think it's a integer value, and they kind of like stand right on the grid like point. So like if I were to put a square at 0, 0, it's going to be it's going to like extend 0.5 in all four directions, right? Um, like let's say this is the x, sorry, this is the x-axis, right? This edge here, and this is the y-axis. If I put a square, it would be like right here in the center, like this, right? So because of that, um, the actual x-axis isn't just a line, it's actually it is a line, but it's a thick line. That's the thick of like the thickness of, oh my god, I better draw that. I cannot. Let me create a new one. Oh, in fact, we can open this unit circle. Let me explain this to you real quick. So if I were to draw the axes here, so this is x-axis, this is y-axis. If I were to draw a cube that is right in the center, right dead in the center, it would be positioned like this. So this is how cube at 0, 0 works. If I wanted to position a cube at, say, 0, sorry, at 1, 0, it would look like this. If I wanted to position a cube at 0, 1, it would look like this. If I wanted a cube at 1, 1, it would be here. But you see how that's not the corner of the cube is aligned to the axis, but the center of the cube is aligned. And this is important in our calculations because when we draw the entire thing, we if we were to align one of the corners to the grid, then it would not look like the character would not look centered on the screen because this is centered. The character would look like a little bit offset. Like it wouldn't be dead center. It would be like on a smaller screen, it's a little bit easier to see if I were to resize this. You can see how if I make it really small, they are not they're not like over here. They're like right dead in the center, right? You can see how like it's just right straight through the middle of the edges. It's not like so this here the center. The edge is not on the center, but the actual center of the sprite is in the center. So we shift everything 0.5, you know, negative I think or positive, doesn't matter which way really. Actually does matter. Well, anyway, so if we want to draw something here, um, actually that's a pretty good drawing. Let me quickly. Try and extend that in all directions. Hang on. So, our character is right dead in the center, but the actual, like the character could be standing a little bit offset. Let's say, um, the character is offset like this. So we need, and then we crop this. We crop this. Where's my black? Let's say we crop it like this. Basically, I want to know how much do I offset this red square into like the edge here, like this way, like towards this point, so that it would look as if the grid is not moving while it actually like, so that the grid looks like it's stationary but the character is moving on top of it. And I'm pretty sure if I were to Google this, it would have brought up the answer. In fact, I should Google it. But I want to figure this out myself because I don't know how to Google it. And, oh, actually, hang on. Tile alignment for 2D games in motion. I'm just jumbling all the words so that I can find the thing. I think this might be what I want. Oh, and we gotta solve floating point precision, by the way, because I don't know exactly at which coordinates, but at some coordinates it bugs out, and you saw that there's like a line, and the reason why there's just a 1 pixel line is because the floating point coordinate before it was like, say, it resulted in pixel coordinate 70, but the next tile only starts at, say, like 71 or 72. So it's not like there's a gap because the floating point math doesn't check out, and it could go multiple times in the screen. We could see that, or at least it would appear as if there's multiple. Maybe they're in different frames, and also they can be they're like all the way like vertical lines and horizontal lines, and they can also be both of them. So we gotta solve that somehow. I think the way we're gonna solve it is we are gonna calculate the offset once, and then we're gonna just add integers instead of adding floats because that's what's causing it. So smooth movement can be achieved in a number of ways. It really depends on what kind of movement you want to allow. Oh wait, that's just no. I won't like calculate tile position relative to the character basically. Hmm. Okay, let's close that. Let's think of it this way. We have a red square. Let me draw that with different kind of red. There you go. We have a red square. It is supposed to be right here, but we move it by some offset off the screen. How do we calculate this offset? The way that I do it is actually kind of weird. Um, I don't think I'm actually representing the 0, 0 properly. Um, yeah, I don't think I'm actually doing it properly. So let's think of it this way. Where is the center? Where is the center of the character? Let's say it's about there. Okay, it's actually not there. Think, yeah, about there, right? Where's the center of the tile? Well, it doesn't really have to be perfect. Let's say there, right? So it's not actually, the center is not there. It's a little bit lower, but it doesn't matter. Point is, we can calculate the offset to the closest tile, basically within which we are, right? Because like if we move slightly, you see how if we move a little bit over here, we're gonna be on the blue tile, and then we're gonna calculate the offset relative to its center. So we know the offset, and we can just say, okay, well, we know that, so we can say that, hey, we know this offset. We are going to move the tile that's in the center um, certain blocks over. Let me just mute for a minute. I'm gonna think about this because I cannot explain it. I just need to like draw out a few things, and I'm just gonna use some paper, okay? Okay, it didn't quite work the way I wanted. Let me do that again. I'm gonna do it this time a little bit different though. So let's do it this way. I'm gonna I'm gonna completely erase the entire thing I drew here. Okay, and then I'm gonna take some um like say some dark colors, just because I think it's gonna be a little better with dark colors. Let's set the pixel to I don't know, 8. Would that be like 16? Maybe. Anyway, what I want to do, what I'm gonna do over here is I am gonna make a checkerboard. Yeah, I know that's probably not the best way of doing it. I do not care though. I think if we just solve it for one axis, it's gonna be enough, because then we can just flip that. Uh, how do we? There's a way of like flipping it. There's a there's a way of like flip and rotate. Uh, there is. Anyway, like you can rotate it like this. I forgot the key binding for it. You could just flip it, and it would be the same thing. Okay, anyway, so let's solve it for one axis. So we're gonna have it as a separate layer. Let's create a new layer. Let's not call it grass, let's call it mask, I don't know, something. Doesn't matter what it is. And on the mask, I'm gonna use a brighter color. I'm actually gonna use green. And here's what I'll do. I will put down, like, say, a green here, and then I'm gonna intentionally um, make a border that's not aligned to the grid. So I'm gonna use like dark green, and let's make that about a 1. So it's just gonna be like this, right? That will be our thing. And now we can move this layer. I think M is movement, no? Yeah, you can see how I can move this layer. I really should crop it though. Okay, now if I move this, should be a little bit. No, it still does the same. I don't want it to move the entire layer, I just want this. Okay, it's just a smaller layer, it's gonna move a little faster. So, can I like somehow align the movement to the grid? Like, if I want to move it, like, okay, anyway, so let's say that this is our character. This is our cutoff point, so we don't see anything beyond that. How do we calculate this offset? Let's just consider one axis. Let's consider the x-axis. So let's say that we are positioned in such a way that we see the entirety of the thing. In which case that is, well, we know how many pixels this is. And essentially, this many pixels plus half of this is exactly equal to, well, actually, is it? No, hmm, you know what? That's not really what we're trying to calculate. Let's align it so that the actual square is aligned to the grid. We know this distance. No, in fact, we know the distance from the center to the edge. How do we calculate the offset of this square? Because that's the square that's on the border. How do we calculate its offset? Well, uh, the thing is, if we just calculate the offset from center of this square to the center of the square that it's within, we are not going to get the right answer, because then this square would be aligned, like it would be right on the edge. But as you can see, the viewport kind of cuts it off. So it's not relative, it has nothing to do, or very little to do, with the position of this square within the grid cell. Instead, it probably has something to do with the distance, basically with the position of this line relative to the outer edge here. We need to calculate that. And then we know the width of the screen, so we know that our offset is going to be within one tile. So we just add another tile, another extra tile on this side, on the other side that we don't see, right? We just add another row of tiles so that we can move this entire screen, like this entire red, just a little bit off to this direction, like to the left. And then on the left, it would still have like a tile to render. So what we need to do is we need to say that we need to know the width of the entire screen. And for that, I'm gonna have to draw another line, which I don't think I can actually draw here because there's nothing. Well, anyway, let's then not draw the line, I guess. Let's just imagine it's there. So we know the width of the screen. We really just need the half of the width. We know half of the... Wait, is it the half of the width though? Or is it the width? Not sure about that. Is it the half of the width? Or is it half of the width minus the size of the tile? What is that? So let me just open, let me just move that to workspace 1, and I'm gonna like press, can I press tab here? No? View, um, how can I, oh, you can configure grid? That's pretty good. I forgot which one makes everything go away. There is like, you press tab and it like, um, it like makes everything but the image go away. But that stuff doesn't work right now for some reason. Oh, it does. Okay, that's better. So let me just select this background. So okay, So let me open up, and I'm pretty sure that stuff is out there. Hang on. Um, Rendering tiles on screen 2D. There should be a math formula for this. I don't want to do it myself. Okay. All right. Let's think of it this way. Let me open up scratch.org, and I'm gonna add another section here. Tile alignment, and we want to know the formula. So we know already. Let me actually do this. Begin. Is it backslash? It's not backslash. It should be backslash like this. Begin equation and equation. We know that our x is equal. So this is the offset that will be applied to all tiles. So this is x offset, right? We know we need to use the position of the character. Um, or let's make it just offset, because we're gonna compute it for axes separately, but the equation is still the same. So the offset would be basically we need to calculate the position of of edge of screen edge, and because it's just one edge, it's a line. So regardless of the y-axis, the x-axis, so for this particular case, in the horizontal kind of plane, or better say axis, so the vertical line will have a specific x position relative to the tile. The y-axis will always change. Here y is 0, -1, -2, -3, -4, right? But the x is always going to be, I don't know, like 50, for example. So we need that position of the edge, and we need to subtract from tile so position of tile, we subtract position of the edge, and that is kind of what it is, right? Position of the tile in the, like, whatever x-axis, y-axis, minus position of the edge. But what is the position of the edge, though? How do we calculate this? Let's say that. I'm thinking. Hmm. Let's think of it this way. The tile, sorry, the character is aligned on the grid. They could be unaligned in the y-axis, but in the x-axis they're aligned. Because we could theoretically just take this layer and like move it up. But that does not change the x-axis, right? The only thing that changes is if it was to move in the x, but let's say it's not aligned on the y-axis. That will still not, will still be okay. So let's say they are like dead center. Basically, their position is the same as if we were to like int position, So anyway, they're aligned on the grid on one direction, whichever we're trying to compute. Then we're trying to calculate local coordinates here. We need to translate the character as close to this line as possible. So what we'll do is we'll start subtracting whole tiles that there is. So -2. So let's say our character is now here. Oh, I'm thinking. So let's say they're here. All right, enough of the. it's a progress bar. It's a loading. Okay, it's just loading. Anyway, so let's say they're here. Then there is some distance here. Let's maybe translate them to this tile. So let's translate them to this tile. So it's gonna be position of the character. Um, no. Wait. It's not the position of the character. It's position of the character on the screen. So position of character on screen. Right? And the position is half the width. So that is width. I'm trying to make a LaTeX so we can actually look at it later. Width of a 2. We are going, it's going to be a float. So we're going to seal that. Seal. We're going to seal that. What is seal? Seal is sealing, short for sealing. And that's basically rounding up, not to the closest, but rounding up, always up. So even if it's, say, 1.1, sealing it would be 2, because 1.1 already has that little bit of like zero point 0.1, and that's already up, going up, so it's going to be 2. And the reason why we want that is because we want to basically translate the character over here, right? So then, once we seal it, we're going to get the position uh, of the character here. Oh, wait a second. Okay, then we are gonna divide that into, I know it looks weird now, it will look okay, into our resolution, which is position to pixels. Actually, let's make that position to pixels. Position to pixels. So far like this. Oh, you can't see that. Oh, yeah, I can't even zoom it in, unfortunately, because of the way LaTeX works. But point is, I really do need more. Hang on. That should bring some. No, there's no space there. Okay, let's then remove this. It's not actually useful. Alright, so yeah, you almost cannot see that. I'm pretty sure. I mean, unless I go into OBS and like I scale it up, I think that's a little better. So that's going to be ceiling of width. Oh, sorry. Ceiling of width over 2 divided by position to pixels. Oh, that looks fucked. You know what? How do I reset this? Okay, there we go. I am guessing instead of this, let's do it this way. It's gonna be easier this way. So, our integer offset equals, what is it? Let's do x offset equals, and this is going to be integer because we are counting number of pixels we need to offset. It's going to be, this will be calculated separately for each tile. It's going to be position that x. You know what? That's all fun and games, but how about how about we actually start writing some code? Because it seems like we're gonna end up writing this anyway. So this is where I actually create this thing. We are going to completely get rid of all of this except for the static cast. Okay, we're just gonna completely ignore everything that we wrote. Let's cast to 0 here just so it's not complaining. And let's start calculating it. So we want, first of all, the position of we want the position of the sprite on screen. We want to translate this over here, basically. Like we want to know. Well, actually, I mean that's always going to be that's kind of useless if we translate it over because well, if we oh, that's what it is. So we can actually do this in two stages. The first stage is we figure out well, what is the alignment we have to do if this sprite was over here, right? And then we can say, oh, but the character is offset by some offset. So then we're just gonna say, well, we're just gonna correct this sprite with the same offset. That's genius. That's just fucking genius. So we need to know basically what is the position of this sprite, sorry, of this edge, or better say this edge here of this sprite relative to this line. We need to know that. So the way we know that, we should probably do this in several steps. It's not really gonna like make it worse or anything. So we're gonna start with calculating position of left edge of the sprite relative to left edge of the screen. I know I never write comments, but this is just so I'm gonna rename variables. Maybe I'll leave those comments in, I'm not sure. But like for this particular math, it might be important later for maintainability so that somebody doesn't have to do all the math again. They can actually fix something if there's something wrong with it. So we need to know what the position here is relative. Basically, we want to know what is this distance here from this edge to this edge. The way we do that is we know the width of the screen. So we know our width from here. And we don't really care about grid width. We just need the raw width of the screen. So we know the width. We can we can say width over 2 and let's make integer offset edge equals width over 2. But here's the thing. If we just do that, it's not going to do it properly. So we need to do a static cast to integer of round. And we're gonna plug this into CPP insights a little bit later. So we know what's the offset on the edge, but that's not actually correct because we know what the width of, basically right now we know the half of the width. We need to then do here percent position to pixels. Now, that might not give us what we want. That's gonna give us basically the smaller part of it. Because like if you think about it, it's going, oh, it's actually gonna give us something really weird. Because like, well, actually, because we are offsetting, we can yeah, we can, because at the end of the day we're gonna offset the entire thing a little bit. We can think of it as basically the distance from here until there, or like the distance from the center or something. So we're calculating everything properly, basically. But we're gonna get... Oh wait, we want the position of the... maybe we are getting the thing. So the actual width is gonna start from the center until here, and we're gonna get this pixel. And we want to know the position of this edge, but for now we're calculating the position of this. So we need... We'll have to offset. Which way do we offset, by the way? We offset... So we add... Oh, I'm gonna have to look up which corner it is. I think it's here to here. Yeah. So why is it adding then? It's weird, actually. That is so weird. Let's start with... We can calculate the position of the edge later. Let's start with calculating from the center to the center. And yeah, then we can adjust. So we're gonna get this little piece. Um, we're gonna get this little piece. So then, if we do that, we actually probably want width minus position to pixels over 2 like this, so that we basically count from this edge until here and we get this piece. And then we need to say that position to pixels minus this. So this is going to be the offset of this is going to be the offset of something. Basically, this is going to give us the distance from this edge to this edge. I drew it in a really weird way. I should have drawn it like a little bit closer to the edge here, this green line. It's kind of dead in the center. Yeah. It makes it hard to think about the things. So then we move the entire thing, I think. But why do we add? Wait, what the fuck do we do? We do minus... We don't actually subtract anything. Look, we do minus position to pixels over 2 plus... what the fuck? Am I right? Look. Position to pixels. Oh, that's width. Oh, I didn't see that. It was width. I thought that this was the same number. Okay. So we get the distance basically from the edge to this. So this is technically the offset we have to apply to every edge for the x. And then the y-axis is going to be the same thing, except it's going to go like the other way. So it's going to be this. So this is x offset, this is y offset. And it's going to be basically, instead of width, it's going to be height. And that's it. But, here is the thing. We know the offset here of the edge. Here's the thing. We know this distance. That distance there is, I really have to like fucking write TDD style stuff, I think, because this is not going much anywhere. But think of it this way. So inside of this static cost, width minus position to pixels. So basically we get this first, and then divide by, wait, no, no, no. We get this entire width, this. What are we even doing here? Oh, we're doing it wrong. Let's do it this way then. Let's do width minus position to pixels over 2 like this. Let's do it this way. Because that's what's actually supposed to be happening. Don't need this anymore, right? So that basically this is going to be width over 2 minus position to pixels over 2. So this is going to give us basically from here to here. We can percent that to get just this. And then we can calculate this bit. And that's going to be an absolute value. But then the sign of that value is what's going to matter. So here the sign does not matter because that's an absolute value. Okay. Alright, I was just worrying about the sign because you remember how on the y-axis it's actually flipped? So we, instead of adding, we have to subtract. Instead of subtract, we have to add. Okay? So this is what I was talking about. This is what I was thinking about right now. So now we're just going to like I should really rename this stream afterwards into calculating offset of tiles based on like a screen edge or something. I had just formulated the most fucking calculating. I misspelled it. Calculating tile position on the screen relative to screen edge. Please. What? What is he doing? Why are you percenting? What are you doing? Ah, this is not what I wanted. Their grid, their tiles are aligned to this. This is exactly the opposite. The character is centered. The character is what's moving. The camera is moving. Oh my god. Oh yeah, yeah. This lines between tiles, I believe this is the vertical and horizontal lines that we've been experiencing. We're gonna solve that once and forever. But we have to first figure out the offset so we can offset everything by the same offset. Because I think what's happening is we end up recalculating it every time and it's just bugging out. So we get the offset, we get this distance. Now, we need to apply that. We need to say that our rect, it is going to be basically on the edge here, right? Um, so the x coordinate is going to be 0. Sorry, the x coordinate is going to be I starting from 0 minus x offset edge think about it. Wait, I times position to pixels. This is just such a nice name, by the way. Basically, that's it. And here we do the same with J. And that should solve everything. That should just solve all of it. But we haven't talked. Actually, there is no character position in this equation. Hang on, that's not what we wanted. That's that does not take into account the character position. That's not what we are gonna expect it to be. Because as you can see, the tiles simply stay in the same position, like if I resize. You see how... Oh, they don't even... The heck? They're not supposed to move relative to the character, though. Ah, I think that diagonal movement, to me, looks like I forgot to change it. It is so funny how after you do some graphics, you end up realizing, oh wait, diagonal movement is probably me not flipping X and Y and like not updating one character. Okay, now this should work. Okay, please. Yeah, okay. So this is pretty good. You see that as I move the screen, the character stays stationary relative to the tiles. And if even if I move, the tiles stay stationary relative to the character. The tiles do not move. Now we need to calculate the offset of the character relative to the nearest tile and apply that offset to all the tiles so they all kind of imagine as if they're moving. Now, because of the way that we calculate this, where we don't do rounding anything, we just like multiply here, and this math should not produce those vertical lines. And now, after we calculate these offsets, we're going to make them into a separate function, by the way. uh, we need to now calculate offset calculate player offset relative to the closest tile. Now, it does matter how we calculate this, and also what matters is the sign. I think the sign does matter. And another thing I want to talk about is the fact that when you go into negative coordinates, and this will happen all the time in the game, even if we are at 9,000, 9,000 in the game, in the physics simulation, we are still at 0, 0, because not because everything moves around us, but because when we spawn in, we make it so that basically where we stand is the 0, 0. We recalculate all the coordinates, and the reason for that is for floating point precision. But anyway, back to what we're talking. We need to calculate the offset in such a way that it would always be pointing, the vector of offset will always be pointing in the same direction. Because otherwise, it's going to be if statements. And we will probably have a few if statements. So basically, if we go in the negative direction, vector was pointing here, it would start pointing from the other direction. We want to fix that. So let's start with just positive. Let's just forget about the sign. Let's just say all of our coordinates are always positive, both x and y. They're always positive. And then we can somehow work out how to make them negative later. We don't need to worry about it right now. So we have this offset. We know the position of the character within the tile. Like within this tile, we know that their center is like here or here or here. You know, we know where they are. We can calculate this. So let's actually do that right now. So we're gonna get their position within the tile. So position of the character in local coordinates relative to the closest tile. I know that's a long sentence. We need to calculate this. So how would we do that? Well, we would say that I want my character to want the character to be located. Oh my god, this is so fucking. This is hard. Alright, so if we calculated, so pretty much it's going to be offset from the center of the tile to the center. So basically, it's never going to be more than 0.5, is what I'm saying. It's always going to be either in the center or here, like, but it's always calculated relative to the center. So basically, the offset will always be. The idea here is here's the idea that I'm trying to explain here. Imagine, so you can kind of see like here's the center of this tile, right? And let's say my cursor is the position of the character. As I start moving, it goes 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.4999999, negative 0.499999, because now we're in the second tile. See how it never goes to 0 0.5? So on this edge, it would be 0 0.5 and negative 0.5 for the other tile. So we always are going to be like a half extent, basically, of the distance. So it's always going to be less than 0 0.5. So if it is, but it does matter. The sign does matter, except that in negative coordinates we flip the sign because negative coordinates are terrible. But let's not think about them. Actually, I think I have a way of. No, no, I don't. We're gonna have to. Anyway, so it's always gonna be this offset within 0.5. Um, Now, I would prefer to always calculate the offset um, as mm, we'll talk about that later. So we always want to know what the offset is in the positive x, and well, let's think of it as positive y for now, or maybe negative y. I'm not sure. Um, well, we'll see, because now we're actually talking. Yeah, okay, this is going to be hard to imagine, but if we are just talking about x direction and we move this way, we need to move all the tiles. Um, so let's say here integer x offset character, or camera actually, not character. We don't talk about characters here. Camera, because we always calculate everything relative to the camera. We don't actually poll the character position. So x offset camera is always going to be within 0.5, and it should preferably be always a positive integer. So we're going to say that it is equal to this. Um, it's going to be always equal to I just realized a little bit of something. Let's not think about it yet. So it's going to be the so we always want the positive offset in that direction. So we want to move the tiles to the left. Always want to move tiles to the left. If we want that, then we need a position of the character camera data the x subtracted camera data that x, but we're not gonna round it, but we're gonna floor it. So floor that, and then and then we calculate all of this as as a float. We no, I'm sorry. We do that, calculate as a float, and then we multiply it by position to pixels, and then we do a static cast to an int on all of this. Um, let's see. There should be another bracket here. Static cast to an int. And that would give us the offset, but actually it's not 0.5. Yeah, I lied to you because it's not 0.5. It is actually from the center to the center. So it can be from 0 all the way to 99999, sorry, 0.99999. It's like almost 1. But if it is 1, it becomes 0 because it's the next tile, right? Because we're flooring it all the time. So, okay, it can be from 0 to 1. So that's the offset to the x. Let's also do the same thing for the y direction. And this should be kind of easy, but at the same time, not really. Because here's what's happening. You need to start thinking, okay, well, this offset, we always want to move down. So if we, let's say this is 1.1, and this is 1. What? Oh, not 1. And this is 1. We need to like take this and like times position to pixels, right? Like this. Um, but actually, we want to say, I guess, 1.f minus this times that. And let me just make sure that that is happening first. So actually, because this is just the like subtraction, we can just do this, where 1 what do we want? We want a positive integer, right? So this should be, I mean, oh, this should be plus, because remove the brackets, we need to flip the sign. Okay, yeah, forgot that we have to flip the sign. So then, times position to pixels. So this should give us a value that is actually pointing downwards, not up, but downwards, right? Where is it? Yeah, the value is pointing. Yeah, okay. Yeah. So that it still is. Yeah, okay. If you want to do this math, you need to do it yourself because I cannot explain everything. I can't. Okay. But continuing on. If now I take. Oh, sorry, my mouse. If now I take this and 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 now I have the offset. So now here, when we offset, we need to minus x offset edge minus x underscore offset camera. So in the positive coordinates, it should work. It just may not work in the negative coordinates. We're going to deal with that in a moment. Hopefully with some math. Oh wait, I have to run it first. So if I now move in the positive direction, you can see I forgot to flip something. Again. It is kind of weird. You could actually make like really weird, like almost hypnotic games just by flipping the offsets, like flipping the x and y axes in the render. Okay, so now you can see we're actually moving. So the tiles seem stationary. In fact, you can see within these squares they are, and you can also see that the screen seems to be filled in, and my mouse is kind of like it's almost dead. The battery is almost dead. But as we get to 0, 0, does it actually work? No. No. Wait a second. No. This can't be. No way. Oh, so then my math was just wrong. Okay, let's see if those lines are gone now. I don't see them. I will admit the pattern is just awful. I know that. You don't have to tell me. Shit. It's actually working now. Let's adjust the speed a little bit. Um, wow. My math works. So we don't actually need any kind of like weird adjustments. It just works. I'm not sure how exactly, but doing it in these steps. Oh, and by the way, it's red, green, refactor. In our case, we don't write tests because I'm lazy. I should have started with tests though, but yeah. I don't even think we have a test system set up. Yeah, I got rid of tests when I was refactoring everything, so I could. I mean, if I really wanted to, I could write tests, but not like I'm going to. So what I was supposed to do, I wanted to adjust the speed. So the speed is adjusted, I think, in the system. I think it's handle events here. Um, yeah, float speed. It's just not good enough yet. So let's make that about a 3, and then this is gonna be about a 10. It's gonna be just wild. Yeah, that's just dashing. I will admit it's a little laggy. When we move like this, yeah, it does look a little weird. I'm gonna need to add some motion blur probably. Yeah, it does look kind of weird. It also might be looking weird because of this is just a black square around the character. But yo, the thing is working. Just test it in like different resolutions. Yeah, if it's small, it's really just looking super done. Um, all right, that is surprisingly good, and we didn't even spend that much time on it. Just just 2 hours. Actually, just 1 hour. Okay, that's done. We can now. Yeah, sorry, I'm having some kind of weird coughs where I don't cough out anything, but I'm still coughing and I can't stop it. And I already took the pills and they don't work. I'm gonna have to. I don't know. Okay. Uh, okay. Actually, I have a thermometer. Sorry for the noise. I have a thermometer here. Maybe I should measure my temperature real quick, just in case. Because if that ends up high temperature, I might need to cancel. Um, might need to cancel the event. Yeah. Actually, I've not thought about that. But that would be good if I cancel the event. It's gonna be just fucking awesome. Yeah. Jeez. All right, peeps. Jeez, I am so happy that this thing is done now, and the math seems to work in both positive and negative directions. Because as you can see here, it is printing at every frame. It shouldn't. Should print a little bit more. Like, actually, you know what? Let's run this again. Um, and I'm gonna walk to like the negative direction, and I'm just gonna make sure that this is the negative coordinates right there. So it does work in negative coordinates. Pretty good. That's actually really nice. Oh, thermometer. What are you saying? It says 36.2. You're a liar. Okay. Do you know that you actually can keep the thermometer, the ones that like, what's it called, electronic? You can keep them in up to I think 10 minutes more, and usually that would be more representative of the actual temperature. Keep that in mind. Not sure how you're supposed to use them. Are you supposed to like put the thermometer in, let it like heat up, and then turn it on or something? Because when it beeps, it doesn't actually tell you the right temperature. It just tells you some garbage, and you're like, that's clear. Just that's not even close. At least that's my experience. Okay, yeah, they are getting close. It's just that I feel like it should be higher than this because I can feel it with my hand that it's higher, probably. Or maybe it's just that my hand is cold. That also could be the thing. So now that this is done, and it seems to be performing quite well, um, we can now start doing more. What should we do? We should draw more sprites. That's what we should do. We should draw more sprites. Okay. Open tile map. Okay, so this is the current tile map, and this looks like goo. Uh, okay, by the way, since I did something, I'm gonna mag it. See, commit. Um, why can I not? Oh, because I need to CC, right? So edit a background. Oh, wait. Before we can commit, I need to exclude the tile map stuff. I think assets are actually ignored by Git. Oh, okay, assets are ignored. Okay. For now, we're gonna ignore them. Edit better added background and I think this was the commit where I removed a bunch of stuff from system.h. Or did I? Yeah, systems.hpp. Yeah. I moved a bunch of stuff. And refactored systems.hpp. And actually, I should say split. Okay. So we should do something about it then. We should like um, we should make this better. And I don't know how. Let's think of how. I need to know how to make it better. So the way to make it better, I think, would be to add another layer called, I don't know, grass or something. And then select this thing, fill with green, edit layer attribute, set it to like, that is just a horrible color. Like, it doesn't matter what I do, it's just horrible. You know what, let's merge it down. How can I? But let's actually redraw the entire thing. So let's first of all, let's fill this with green, but not this green. Maybe this. Yeah, seems to be nice contrast. So then I'm gonna take the same green. I'm gonna like darken it a little and maybe make it look a little greener. And then I'm gonna take my pencil. I'm gonna make sure it's really nice and fine. And actually, I don't want my pencil. I want my paintbrush. And I'm just gonna end up like doing random lines. Now, here's what you have to do. You have to select this, copy, paste it, make it its own layer. Move that over, paste it again, move it, and paste it, move it. Um, then you merge that down. Then you carve out the center part. Actually, before you carve it out, you just take your brush, you add some grass right there, on the edge, right? So you do that, and then you take your the crop thing, and you go 8. What should it be? It should be like basically center. Uh, Hang on. Oh wait, can you like select, move here, Control X, and then I think just paste it. Say, if you just Control V, make it a layer, delete this, take this. Um, oh, it's not big enough. Okay, cancel that in there. Huh. Interesting. Let me try that again. I'm gonna take this. Yeah, I guess I didn't make it big enough. So then you Control X, you delete this layer, and then you paste in this, create it as a layer, rename it like, I don't know, grass or something, whatever it was. And in some, I know in Photoshop they have a special tool for this where you can, I'm pretty sure GIMP also has that, where you can basically offset the picture within this frame by like some amount, and it loops back around. But I just do this, and then if there's any kind of like weird stuff going on inside of here, it doesn't line up perfectly, you can just add in more detail. But for now, I'm gonna keep it this way. And all you have to do is you just save this, and also you export, and Control E. Oh, it doesn't export. It doesn't export in the same place that I want it to. I wish you could write inside of this thing, because you have to like find CPP sand assets. Yeah, export. And now it immediately loads, and oh, you can still tell. You can still tell. You can still tell. Yeah. I don't know. I'm not gonna fix it. This is looking a lot better. On my second screen, it looks kind of terrible, but it is a nice color in my opinion. Um, and you can actually then later add like different hues. I'm not gonna do that right now because I don't see a reason to. But there you go. Still have the boxes. I think we should draw some boxes. And for now, I think what we should do instead actually is we should get rid of this black. So how would we do that? Well, that would preferably be done in GIMP. So I would preferably what I actually would do is I would take this thing here, I would go here, and I would just like erase this away. What? Oh, it doesn't actually erase. It just replaces it with this color. What? What if I want like What if I want transparency? RGBA. What if I do this? No? I really want transparency. Let me think of it. Okay, oh wait, what if I do this? Oh, delete. So actually, hang on, fill all that in. Alright, I can actually just hide it, I guess. Save it, export it. And that should theoretically be... Oh, that was as easy as that. I will have to clean up the character though. Okay, and it does look kind of good, to be honest. We don't have any kind of animations or anything, but... Also, what's the temperature that I measure? 36.9, okay. Guess my hand is just too cold. um... Yeah, looking pretty good. So, here's the thing. We just have two sprites right now. We have the grass, and we have the... Oh, shut up, thermometer. I want to turn you off. We have the grass, and we have the character. So for now, the only way and then we also have the boxes, and the boxes, they are just boxes, okay? They don't have anything special to them, and they're just white boxes. I want um I want something better. I want the boxes to have sprites on them, but I actually don't want the boxes. I want walls and fences and stuff like that. So I think that let me take a look at the time. So it's currently 1:30. I think we're gonna end now on this really good note that everything works and everything's cool. Um, but we're gonna come back later and we're gonna see um, I really want to fix the hair. I can't, cause it just looks horrible. Yeah, that looks a little better. She's a bit fat though. Yeah, so okay, that's done. So next stream, I think we're gonna spend some time trying to get a bit of um, a bit of a bit of the what's it called? A bit of the more sprites going and maybe draw something because really it's just going to be like, oh, I want to like build a wall. So we're gonna draw like a sprite for the wall and we're gonna code up something that like displays this wall and you know that. Um, but also I want to know like, hey, it would be really cool if we could somehow. So let's open up HTOP while we're talking. Let's open it up over here. I just want to know how much it takes in terms of. Mhm. So CPU. Eh, I mean it is idle right now. Nothing is happening, so it shouldn't take as much. But it is rendering. I'm not sure exactly what's taking this much CPU, but it seems to be kind of fine. Emacs, it says 92, sorry, 91.3. I'm not sure what those numbers are. Those are, oh, it can't take, is it like relative or is it absolute? Hmm, I am not sure. Well, anyway, it's not taking as much as I would think it would. Um, the thing that's most likely taking CPU, um, it's taking CPU. The thing that's taking CPU is I have no idea how to read this. Yeah, I have no idea. Let me hang on. So it doesn't seem, yeah, CPU seems to be always 0. What the weird. So it's not taking, you know, as much CPU as like I would expect it to. So actually I expect it to take 0%, but I don't know, like if we go over to here, you can see we got like top 5 processes and it's, I mean, Emacs is among them, and this program is run by Emacs, but I don't think that this actually that could be. Actually, I think it is taking a lot of CPU. Actually, it might be. It might be taking too much. Hang on. Um, I mean, oh wait, it's not gonna work this way because it doesn't have any assets. Because of that, it's not gonna work, of course. Because I have to cd cpp send, and then we have to execute this. Just that thing. And that shouldn't take a lot of CPU power. Also, when it's not focused, when it's like not visible, I think it should not render as well. Like it should just process collisions and stuff. And then if there are no collisions happening, it should just stay idle. Let's see if I play this thing. Let's actually do some like collisions, speeding up and all that. It doesn't seem to be doing anything really. Like, it's not taking as much as OBS. I don't know how to measure performance, okay? You're gonna be mad at me because I don't know how to, but like, I don't. I don't know. But like, it would be funny if it's like the sixth process it's running. Yeah. Well, anyway, that's it for today. We have something working finally. Not, visual glitches, but actually working. And we're gonna continue next time.